Hey, look, looking into factorizing, which is another important part of algebra. So last session we went through expanding, which is essentially expanding brackets to include the values from the outside using something called the distributive law. Now today we're doing factorizing, which is essentially reversing that process and going from two terms, taking out a common factor and leaving the rest inside brackets. So think of it like the reverse of the distributive law to undo what that step does, right? Now, before we can do that, we need to essentially figure out what highest common factor is. All right, so it's a term that gets thrown around a bit, HCF. Highest common factor is the highest possible number that both terms can be divided by, right? Cleanly. I'm not going to say at all, because you could divide them all by a billion and make them fractions. But when I say cleanly, I mean so that once they're divided, one is the lowest outcome, I guess. So essentially, what is the largest number you can divide both of these by without turning them into fractions? So let's have a look at a couple of examples I've got here. So we have 2 and 10, right? Now to find the highest common factor, generally speaking, I would write out, we got 2, the factors of 2 are of course 2 and 1, right? And we've got 10, factors of 10 being 10, 5, 2, and 1, because 1 times 10 is 10, 2 times 5 is 10, okay? So that's why we've got those factors there. So now, which of these are common factors? Well, they both have the 1 in common, as all numbers do, and they both have the 2 in common, meaning the highest common factor is the factor with the highest value, which in this case is 2. Right? Highest common factor of 3x and negative 9. Right? So let's have a look. What can 3x be multiplied by doing, I guess? You could have, this makes it a bit more interesting because you could have 3 and 1, right? It's not just a regular 3 and 1 because there's also an x involved here. So it's 3x and 1, or you could have 1x and 3. Right? They're the possible factors of 3. 3x times 1 would give you 3x. A 1x times 3 would give you 3x. That doesn't really matter. Either of those two are possible solutions. And then for the 9, or negative 9, I should say, all right, the negative 9, we have got 9, 3, and 1. Notice we don't have any x's on this side, so that's going to automatically rule out our 2 x's in there, but it's a good habit to get into writing them down anyway. So we have 3x, which is not it, 1x, which is not it. Both numbers have 1 and 3 in common though. Right? So 1 and 3 in common, highest common factor being 3. Right? Now, if both these numbers were negative numbers, I could look into, say, a negative 3 or something like that. But, yeah, anyway, you get the idea. I'm not going to go through the whole lot of them in the same way as I've been doing. You can do that on your own if you would like. 15a and 20b, the highest common factor is 5. This 15 can be divided by 5 cleanly, and so can 20. This next one, negative 8 and negative 20, well, both of these are negative numbers, so my highest common factor is most likely to be a negative number as well. And what do we have? We've got 4, which goes cleanly into both of those two things, so that's probably what I'd be going with. Just loading up my notes here because I have this one written down. Yeah, I think 4 is the right way to go. All right, so 4 is a good way to go, and we're going to keep it as a negative because we want to. When you have two negative numbers, it's always a good habit of getting rid of that negative number. So I should say, technically speaking, this isn't the highest common factor. 4 is the highest common factor, but because both numbers are negative, you always want to try and get rid of that. So that's why we would essentially use -4 as the highest common factor. Now this time we've got x squared and r, right? Both negatives. So I'm going to take out a negative and use that as my highest common factor so I can get rid of them, and it'll make more sense once we get into the rest of the expansion. But essentially, there is no number that can be divided cleanly into both of these two letters, right? Which means that 1 is the highest common factor, right? So we're taking out a -1, right? So let's actually look into a couple of examples and get used to this, all right? So let's look at 4a times 8, and there are some steps along the way that I'm going to show you. I'm going to highlight them as I go, so you can get an idea of what I'm doing when. So first step, find the highest common factor. So my two terms are 4a and 8, right? Now there's a number of factors that could be into 4a because it does have a letter there, but let's have a look at what we've got. I could have 4 and say 1a. I could also have 4a and 1. I could have 2a and 2. They're my possible values that could multiply by 4a, right? Because 2 times 2a will equal 4a. 1 times 4 will equal, so 1 times 4a will equal 4a, and 1a times 4 will equal 4a. It might be easier for you to do this in pairs if that's what you prefer. If you want to write it like this and say 4a, and I've got, 1 and 4a, 2 and 2a, 4 and 1a. And you can write it any way that you prefer. But I need to identify which are the common factors with 8. Now, as you notice, 8 doesn't have any a's, so I can save myself the trouble of trying to write down these a's and just be over that, all right? But let's look into it anyway. So obviously we've got 8 and 1. We've also got 4 and 2. And I think that's it, right? 8, 1, 4, and 2. Highest common factor between these two is 4, all right? Step 1, highest common factor equals 4, right? Done. Cool. That's me finding my highest common factor. The second one, it says divide each term by the highest common factor. All right, divide each term by the highest common factor. So I do 4a divided by 4 and 8 divided by 4. All right, that gives me just a, or 1a if you'd like, and 8 divided by 4 gives me 2. Okay. That's my step 2 done. And we should put the plus back in the middle too, just to say that this is a plus. All right. So the next step says put the highest common factor outside some brackets. All right. So outside some brackets, I'll just do this on the next line. All right. I'm going to put the highest common factor being 4. I'm not going to close this bracket yet, just because I'm going to wait and see how long the expression inside is before I do that. So it's that one. So I put the highest common factor outside brackets. Easy. And the last step is to put the new terms, which are a plus 2, inside the bracket. A plus 2. Beautiful. And that's my last step. Right. So as you can see here, it says my answer is 4a plus 2. Now, an additional, if you want to check to see if you're right, all right, so you don't have to do this because this is going to undo your work, but this is obviously my answer here. If you want to use distributive law to check if this equals this, then you can do that. So let's check. We have 4 times a plus 4 times 2. 4 times a is 4a, plus 4 times 2 is 8. That still equals 4a plus 8. If you check it and this doesn't equal this, you've made a mistake somewhere along the way. All right? So let's try another one. So we've got 22e and 24. Now, there aren't a whole lot of factors for both of these numbers. However, I can see that because there's only a letter in this one, there's no e in this one, I'm not going to bother writing down the e's as factors, because otherwise you get a whole bunch of factors just like this. I'm going to try and keep it simple, because I know that e is not going to be one of the common factors. So, if we have 22 and 24 as our numbers here, common factors of 22 are 22 and 1, 11 and 2, and that's it. There are heaps of factors for 24, 24 and 1, there's 12 and 2, 6 and 4, 8 and 3, probably more that I've forgotten. Maybe that's it. I think that's it. All right. So they're the factors of 24. There's a few of them. Okay. And you could write these all in reverse as well if you wanted to, but I'm not going to go through all that trouble. So I found my factors. Now, which of these is the highest one that they have in common? Well, they don't both have 22 or 11. So 2 is my highest common factor. Right. So now, following these steps up here, I'm going to divide both terms by 2. So 22e minus 24. Both of these divide by 2, which gives me 11e minus 12. All right, and then I write the highest common factor outside the brackets, 2, and I write my new terms inside the brackets. That's my answer there. All right. Done. Just so it stands out amongst all that working out. That's my answer. All right. So I can do this, keep doing this for the rest of these problems as well. Now, this one here is a bit more of a challenge because I have 3 terms, right? There's a couple of things that you can do here. You can try and isolate 2 terms on their own, but if you can find 3 common factors, a common factor for all 3 terms, you can take that common factor out, right? So I might, I'm probably going to run out of room here, but the common factors for 6, we have 6 and 1, 3 and 2, all right? They're the common factors for 6. Common factors for 9, we have 9 and 1, 3 and 3. That's it. Common factors or the factors of 63, we have 63 and 1, 9 and 7, and 21 and 3. I think that's it. I could be wrong, but I think that's it. Now, looking through here, there are a whole bunch of factors that are common to 2, but is there one that's common to all 3? In this case, I do have a factor that is common to all 3, being the number 3. If I didn't have a factor common to all 3 other than 1, I would pick the highest common factor of just 2 of these values and only do brackets around those 2 and leave whichever one was out alone. So, for example, if I had 9, there's no other common factors except for 1. I have 9 in these 2 values here. I could just take the 9 out of these 2, but I have a factor for all 3 being the number 3. So now I'm going to divide each term by the number 3. That gives me 2 plus 3y plus 21r. Right? And then I take the 3 outside, brackets. That's my answer there. Yeah. I'm just aware that my page is a little bit cramped, and that's why I'm trying to highlight these answers to show you. All right, let's do another one. Here we go. -2 and -8. All right. So for -2, before I say that though, I'm looking for my highest common factor. Remember what I said earlier about if both values are negative, see how this is negative 2 minus 8. Both values are negative, I'm going to make my highest common factor a negative. So I have 2 and 8. In this case, 2 is divisible by 2 and 1. 8 is divisible by 8, 2, 4 and 1, which means my highest common factor is 2, but I'm going to take out negative 2 from both of these values here. So I'm going to divide both of these values by minus 2, all right? So negative 2 minus negative 2, I should split those up. I'm dividing both of these values by negative 2. Let me redraw that. There we go, that's probably a bit clearer. So negative 2 divided by negative 2 gives me positive 1. And negative 8 divided by negative 2 gives you positive 4. All right? And it's important with this second one to remember what sign you have, because that is how you get whether it's a plus or a minus. Right? If that answer was negative 4, it'd be minus 4. But if it's positive 4, it's a plus 4. So in brackets, I have 1 plus 4. Outside those brackets, I'm going to put my negative 2. Well, I put my R, so 4R. 8R. Yeah, that still works. All right. Next one, I've got 4AB minus 8A. So now this time there are letters involved. The simplest way to go through and do it if there are letters involved is to find the highest common factor and then identify any common letters or common pro-numerals and deal with them individually. It would be my advice. You could do it the way that I did it before, where you identify all possible factors. That's fine too. But how about I'll do it both ways, and you can pick whichever one you prefer. So for 4AB, all right, my factors of 4AB is I have 4, 2, and 1. They can be in a number of different combinations. For example, they could be, I should have written these as pairs. Could have been 4A, B and 1, or 4A and 1B, or 4A, 1B, could be 4 and 1AB, right? You can see why this gets a little bit confusing doing it this way. You have 2A and 2B. There's a whole bunch of mucking around with that. So let's do it the other way. So this video has been a little bit of a disaster right now, but that's okay. It's important for you to see that even people who do maths do stupid mistakes all the time. All right, let's just do it the normal way. Highest common factor. Right. So I have a 4 and a minus 8. Right. Factors of 4 being 4, 2, and 1. Factors of 8 being 4, 2, 1, and 8. Right. So my highest common factor in this case is 4. Now, are there any letters common to both? Well, you'll see that there is an A common to both. So I'm going to take that A as a common factor as well. All right. So now we divide both of these values by 4A. So 4AB minus 8A. We divide both of them by 4A, which will give me, well, the two 4's cancel each other out. The two A's cancel each other out. So I'm left with B minus the two A's cancel each other out. I'm left with 8 divided by 4, which gives me 2. Put that in brackets. B minus 2, and outside the brackets, I'm going to put my 4A. All right? Let's do another one. If you haven't done this already, I would encourage you to try and stop the video now and give this one a go. And then watch my explanation. So give that a shot if you haven't already. Okay, so assuming that you tried to, sorry, I just need a glass of water. Assuming you tried this on your own, let's see how you went. All right, factors of 2, we have 2 and 1. Factors of 5, we have 1 and 5, and that's it. right? So in this case, our common factor is 1. Now normally, when you have a 1, you don't bother taking it out of the brackets because it doesn't change anything. However, in this case, we will, purely because there's a common letter as well. Right? So 1x, or just x. If I divide both of these values, 2x squared plus 5x, by just x or 1x, doesn't really matter, it's the same thing, we get 2x plus 5. They'll cancel out. Remember, index law is 2 minus 1, it gives you 1. Right? So I get left with 2x plus 5. Remember, I put this single x outside the brackets. Fine. Last one. Similar setup to before. We have highest common factor. Now factors of 6 are 6, 2, 3, and 1. 6 times 1 is 6, 2 times 3 is 6. For 12, we have 12, 6, 4, 3, 2, and 1. All right? Because we have 12 times 1, 6 times 2, 4 times 3. So the highest common factor of both of these is 6. Highest common factor equals 6. Common letter is x. But it's not just x because we have 2 x's here. We have 4 x's here. So it's actually x squared. So I can take out 2 x's from both of these. So I have 6x to the power of 4 divided by 6x squared. And I'm subtracting away 12x squared divided by 6x squared. All right. So what does that leave us with? Well, 6x to the power of 4 divided by 6x squared. The 6's cancel each other out. And now we've got x to the power of 4 divided by x to the power of 2, which gives us x to the power of 2 as an answer. Right? Minus 12x squared divided by 6x. Right? 2x's cancel each other out. Both with 12 divided by 6, which gives us 2. And then outside the brackets, I'm going to put that 6x squared. And that's probably a harder one, but that's how it works. So hopefully you found this example to be beneficial to you, or at least somewhat interesting. I apologize for the length of the video, but that's it. All right, so enjoy the rest of your day. Bye.